This is the Math 2 lesson summary video for the lesson entitled Curbside Rivalry. In Unit 5, Lesson 5, the purpose of this lesson is to utilize our techniques for changing the forms of a quadratic function. We have been studying how to factor, how to complete the square to put the quadratic function into vertex form, and how to use the quadratic formula to find the x-intercepts. In this lesson, we will use all of these methods as ways that we can solve a quadratic equation. In summary, some ways that we can solve a quadratic function: we can factor, we can algebraically put it in vertex form to factor, we can use the quadratic formula, or we can use tables or graphs. Some vocabulary from this lesson are the terms roots or zeros, which mean the same thing. They are asking for the x-intercepts of a quadratic function, or the x-values that make the quadratic function 0. In previous tasks, we have been working with quadratic equations in the form ax squared plus bx equals c. In this task, we will look at quadratic equations in the form ax squared plus bx plus c equals 0. In Curbside Rivalry, Carlos and Clarita want to make some money over the summer and have decided to paint team logos on curbs or driveways for others in their neighborhood. After some research, it was decided that each curbside logo will require 48 inches squared of paint. A driveway mascot will require 16 feet squared of paint. And surveys show that the twins can sell 100 driveway mascots at a cost of $20, and they will sell 10 fewer mascots for each additional $5 they charge. This information will be important as we progress through the lesson. If a curbside logo is to be designed in the shape of a square, we know that we can find the area by multiplying side by side, or side squared. If each curbside logo is to require 48 inches squared of paint, we need to solve the equation x squared equals 48 for x in order to find the dimensions of the sides of the square. To cancel out a square in math, we will take the square root of both sides. That means that the dimensions of our square, if we find what the square root of 48 is approximately, will be 6.93. Now, whenever we take the square root of both sides, we must always include the positive and negative value. However, it's not possible for us to have a negative length. Therefore, we know our only possible value for the side length would be approximately 6.3. So our square would need to be a 6.93 inch by a 6.93 inch square. Carlos and Clarita realize that a square logo will not fit nicely on a curb, so they start experimenting with rectangles such as the one shown. Carlos likes the look of the logo with a rectangle in which it is 8 inches longer than it is wide. Therefore, we can label the sides of the rectangle as W for the width and W plus 8 for the length, being 8 inches longer than the width. Since they will still need 48 inches squared of paint, we need to solve the equation W times W plus 8, because that will give us the area of the rectangle, and we know that we will need 48 inches squared of paint. Therefore, we need to solve this equation for W. We'll distribute the W and get W squared plus 8W equals 48. We can see that this is going to be quadratic because our variable is squared. If we subtract 48, we will get the equation W squared plus 8W minus 48 equals 0. In our previous unit, we discovered how to factor a quadratic equation where a is equal to 1. We know we can factor this quadratic equation if we find two numbers that multiply to our c value and add to our b value. If we think of the factors positive 12 and minus 4, we know those multiply to negative 48 and add to 8. Therefore, we can factor this quadratic into W plus 12 times the quantity W minus 4 equals 0. We can set each of these factors equal to 0 to solve. When we solve, we will get lengths of -12 and 4. However, it's not feasible for us to have a width of -12. Therefore, our possible dimension will be a width of 4. So our dimensions for this rectangle will be 4 inches by 8 plus 4, which is 12 inches. In number 4, we are asked what two different strategies would be used for us to solve the equation from number 3. Well, we have already solved it by factoring, but another possible strategy that we used in our previous lesson was the quadratic formula. If we solve using the quadratic formula, we know we need our a, b, and c values. Our a value is 1, our b value is 8, and our c value is -48. We're going to plug this into the quadratic formula. Negative, in parentheses a, plus or minus, the square root of 8 squared minus 4 times 1 times -48 divided by 2 times 1. If we simplify this, we will see that we get -8 plus or minus, under the square root, we are going to get 64 plus 192. Therefore, that is the square root of 256 divided by 2. -8 plus or minus the square root of 256 is 16 divided by 2. Therefore, we have two equations, -8 plus 16 divided by 2, and x equals -8 minus 16 divided by 2. So our solutions will be x equals 4 or x equals -12. We can see again that this -12 can never be a length. Therefore, our only solution is 4. In number 4, we were able to show that we can also solve this quadratic function by using the quadratic formula. Looking now to number 6. After much disagreement, Carlos and Clarita now want to design a Curbside logo that is 6 inches longer than it is wide, such as in the diagram here. We need to try then and solve the equation w times w plus 6 equals 48. We see that when we distribute the w, we get the quadratic function w squared plus 6w minus 48 equals 0. However, in this equation, we cannot factor it, as there are no two factors that multiply to -48 that add to 6. Our only option in this one is to use the quadratic formula. If we use the quadratic formula on w squared minus 6w, plus 6w minus 48 equals 0, we're going to plug in x equals -b plus or minus b squared minus 4 times a times c divided by 2 times 1. When we simplify, we get -6 plus or minus 36 plus 192 divided by 2. 36 plus 192 is the square root of 228. Now the square root of 228 is not a nice perfect square. If we go back here, I've already typed that in my calculator, -6 plus the square root of 228 divided by 2. One of my solutions here highlighted should be approximately 4.55, and x should also be approximately -10.55. But once again, we can't have negative length. So Carlos and Clarita must make sure that one of the dimensions, the width, will be approximately 4.55 inches. Moving along then to number 7. Instead of painting a Curbside logo, we are actually asked to paint a driveway mascot. Driveway mascots require 16 feet squared of paint. That was provided at the beginning of the lesson. Therefore, we will need to solve the equation w times W plus 6 equals 16. Like we've been doing through this lesson, we will distribute the W to get a quadratic equation that looks like this. We definitely can factor this because we have two factors that multiply to negative 16 and add to 6, and those two factors will be W plus 8 and W minus 2. When we set these factors equal to 0 to solve, we get width will be negative 2, and negative 8, and the width will be 2. We cannot have the negative length, so we know our width would have to be 2. That means our width is 2, and our length is 8. So we will have a 2 feet by 8 foot driveway mascot. Now let's progress to number 9. In 9, we are now focusing on the number of driveway mascots we can sell. Carlos and Clarita already know and have done research that they can sell 100 driveway mascots at a cost of $20, and that they will sell 10 fewer mascots for each additional $5 they charge, which was given to us at the beginning of the lesson. If we fill in the table provided, which I've already done for you, we will be decreasing the number of mascots 10 each time that the price goes up $5. An equation to match this data would be, because our starting value is at 100, we know that our starting or y-intercept will be 100, and each time we are going down by 10, so our equation would be minus 10x as a slope. The graph of this function would be a linear function, and that's graphed here to the right. Now if we take a look at number 10, we are then asked to write an equation for the price of a driveway mascot for each $5 increments, x in the price. We can fill in our table adding 5 each time, which I've done so here, and the equation to match this table would be, we're starting at 20, which would be our y-intercept, and we're adding 5 each time. So the linear function 20 plus 5x, which is graphed here in green. Notice that the red graph from above, 100 minus 10x, is in red, and the new function is in green. Skipping to 12, we are asked to find the revenue that the twins will make from this business. And in order to do so, we will need to multiply the function for the number of driveway mascots, which was 100 minus 10x, times the function for the price of the driveway mascots, which was 20 plus 5x. So essentially, we will need to multiply 100 minus 10x times 5x plus 20. But the twins want to make a minimum amount of revenue of $12.50. That would mean that we would have to multiply these two functions and set it equal to $22.50. If I skip to the next page, I've started that math for us here on the left. I've distributed the two functions, and I've simplified to get the function negative 50x squared plus 300x plus 2,000 equals $22.50. If I subtract the $22.50 from both sides, I'll be left with the equation negative 50x squared plus 300x minus 250 equals 0. The first thing we want to look for is a GCF, and we notice that negative 50 is a GCF. If we divide all three terms by negative 50, we'll be left with x squared minus 6x plus 5. We can go further on this and factor the x squared minus 6x plus 5, which would end up giving us the factors x minus 5, x minus 1, and all of that equals 0. When we're asked to solve, negative 50 doesn't equal 0. That doesn't mathematically make sense. So we don't need to set that equal to 0, only our factors, and solve. Therefore, x equals 5 and x equals 1. What this means is that for the twins to reach their desired revenue of $22.50, they will need to sell 90 driveway mascots for $25 each, or 50 mascots for $45 a piece. We can see this if our x values are 1 and 5. If we go back to the previous page and we look at our x value here of 1, let me use a different color, and our x value here of 5, and our x value here of 1, and our x value here of 5. So we'll need to sell 90 driveway mascots at $25 each, or 50 driveway mascots at $45 each. In summary, we have learned how we can solve a quadratic equation by factoring or using the quadratic formula. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.